Okay, so let's go through two examples of conservation of momentum. So this first one says, a rock with a mass of 17,000 kilograms slides with a speed of 25 meters per second. The rock suddenly explodes into two pieces. We're given a mass and some velocities, and we want to know what the velocity of the second piece is. So with momentum problems, the first thing we're going to do is just draw before and after pictures. So before, I've got this massive rock, 17,000 kilograms. It's moving with a speed of 25 meters per second. And then afterwards, it explodes into two pieces. So one piece is got 9,000 kilograms, and it's moving with a speed of 24. Lies. It's moving with a speed of 14 meters per second. And then I've got this other mass, which conservation of mass is that this thing is going to be 8,000 kilograms if it started at 17,000. And I don't know what its speed is. So I'm going to say V2 final, and I don't know what that is. All right. So conservation momentum says that my before momentum has to equal my after momentum. So if I think about my total initial momentum, that has to equal my total final momentum. So the only thing I have moving before is this 17,000 piece. So it's like I've got my total mass times the initial velocity. That's my initial momentum over here on this side. And then afterwards, I have mass 1 V1 final and mass 2 V2 final. And I could plug some numbers in. My total mass to begin with was 17,000. My initial speed to begin with was 25. So that's my before side, and that's an equal to my after side. So afterwards, I've got this 9,000 kilogram piece that's moving at 14 meters per second, and then I've got this 8,000 kilogram piece, and it's moving at I don't know. And so I could calculate this out. So on my before side, 17,000 times 25, that is 425,000. And then 9,000 times 14, that is 126,000 plus 8,000 V2 final. And we should be able to subtract over the 126,000, divide by 8,000, and you should pause the video, and you should calculate out what you get for V2 final. I will tell you, you should get 37.4 meters per second. And the fact that it came out positive means it's also moving to the right, because everything in our picture moving to the right is a positive value. Okay, let's look at this next one. It says a 2-gram bullet with a velocity of 538 meters per second strikes a 0.25 kilogram piece of wood on a frictionless surface. The bullet remains in the wood. What's the final speed of the bullet block? So again, let's do before and after pictures. When you have collisions or explosions, we always want to look at it through the lens of momentum, and we are going to start with before and after pictures. So before, there's my little bullet, and it's moving pretty fast at 538 meters per second. I should draw this a little bit more space. There's my bullet, 538 meters per second. Afterwards, it is embedded, and I don't know what its final velocity is. So before and after pictures, let's look at before and after momentum. So initial total momentum has to equal my final total momentum. So initially, I've got the mass of the bullet times its initial velocity. Afterwards, I have the mass of my bullet plus the mass of my block times some V final. So let's go ahead and plug in my numbers. Mass of my bullet. My bullet is 2 grams. I got to convert that to kilograms. So 0.002 kilograms times initial velocity of 538. On my after side, I got 0.002 plus 0.25 times V final. And you should be able to calculate this out. I am going to leave this as a come back to class and see if you get the correct final velocity value.